Okay, we finished the graphing portion of 6.4 on logarithmic functions, and now we want to solve some logarithmic equations. We're given here some steps for doing that. When solving simple logarithmic equations, follow these steps. Isolate the logarithm if possible, change the log to an exponential form, and solve for the unknown variable. Okay, so an example of 7a, we're to solve this equation and leave our answer in exact form. Okay, so it says to isolate the log if possible. So the log of this argument is by itself on one side of the equal sign, so that's already done. Step 2, change the log to exponential form. So change it from log base 2 of 2x plus 1 equals 3 to the base 2 to the exponent 3 is equal to the argument 2x plus 1. Notice how simple this is going to be now to solve for x. 2 cubed is 8. Subtract 1. Divide both sides by 2. And we'll leave it as an improper fraction in simplest form and put our solutions in a solution set. That's the exact answer. Now you could check it, put 7 halves in here. What's 2 times 7 halves? It would be 14 halves, or 7. 7 plus 1 is 8. So we'd have the log of base 2 to the base 2 of 8 is 3. 2 cubed is 8. Yes, it checks. Okay, let's do B. And now in B again, we're going to change it to the exponential. We're going to change it from its log form to its exponential form. The base is x. The exponent is 3. The argument is 343. So I wonder if 343 is a perfect cube. So you just take the cube root of both sides, right? And let's see if it is a perfect cube, then we'll get an integer. Is 343 a perfect cube? What do we cube to get that? 7. So in our curly brackets, we'll put our solution of 7. 7 to the third is 343. Okay, so the first two, step 1 was unnecessary. We were already isolated, but in C, it is not. We have a 6 minus log base, base what? What is the base of this log? 10, yes, it's our common log of x equals 3. So let's subtract 6. And multiply by negative 1 to get log base 10 of x equals 3. All right, and now let's change it to an exponential. The base, again, what's the base of our exponent? Exponential is 10. 10 to the third equals the argument. So what is x equal to? 10 cubed is 1,000. Okay, so the log base 10 of 1,000 would be 3. All right, in D, again, we're changing this to the exponential. So what's the base? The natural log of 2x equals 5. What's the base? Well, for the natural log, it's e. What's the exponent? That's what the 5 is. E to the 5 equals 2x. We're solving for x. I'm going to put it on the other side, and let's rewrite it this way. I just like my x on the left, actually. Divide by 2, e to the 5th over 2. Remember, e is a number. That's not a variable. It's a number, but it's an irrational number. So we don't want to raise e to the 5th power and divide by 2, because if we do, we will not get an exact answer. We'd have to round at some point, and it would then be an approximation. So our solution in exact form is e to the 5th over 2. It would be, if you raise e to the 5th, divide by 2, you get something like 74.2066, something. But this said exact. That's the only way I can be exact. Okay, and now we have in e, the natural log of x equals 2. So what's the base? The base raised to the exponent equals the argument. Yes. And so in exact form, that's it. E is an irrational number and E squared is an irrational number. Okay, and finally, our log is, as it was here, it's isolated already. So the base is 6, the exponent is 5x plus 3, writing it in exponential form equals the argument 36. Okay, well, to solve this, notice that I can write both sides with the same base. 36 is 6 squared, so 5x plus 3 must be equal to 2 for that to be true. So 5x, subtract 3 from both sides, equals -1, divide by 5, x equals -1/5. So that's my solution set, -1/5. We could plug it in, and that would be -1, and -1 plus 3 is 2, and 6 squared is 36. Okay, let's look at the next example. We have G. Right, so again, what is our base here? It's the natural log, so the base of the log is E. The power is 8, and the argument is e to the x. The base to the power equals the argument. So what is x equal to? Clearly, x is equal to 8. What is the base when we have log with no subscript of 1,000? The base here is 10. 10, the power is x. So 10 to the x equals 10 cubed. 1,000 is 10 cubed, so x must be 3. Okay, so we want to be able to fluidly go from a log expression to an exponential, and then we can solve for the variable. Whoops, didn't mean to move it out of the camera. Can you see that? I hope you saw all of that one, though. 10 to the x equals 1,000. We wrote 1,000 is 10 cubed. We see x equals 3, and 3 is in our curly brackets.